Precalc, Mr. Messner coming at you with the homework 2.1. What are we talking about? We're talking about polynomials. Okay, polynomials, cool equations. We are going to figure out what these cool equations look like. Okay, to the best of our abilities as of right now, what does this polynomial look like? Now, what is a polynomial? A polynomial is like a bunch of x to powers added together. Any number, any numbers before it, et cetera, et cetera, et cetera, all the way down to just like a constant. And we're just going to get into like, what does it look like? What is some things we can tell about it? We're going to analyze polynomials. First things first is we're going to find the zeros, points where the polynomial could possibly like cross the x-axis. So zeros are just setting the equation equal to zero, finding the solutions. Now we use the zero product property to solve this. We figure the x values. Let's look at both of these at the same time. The x values that will produce zeros. Now we look at all of our pieces of our product, and whenever a piece of the product equals zero, the entire thing will equal zero. So when I plug in 3, 2 times 0 times negative 1 to the fifth, that's a 0. When I plug in 4, 2 times 1 times 0 to the fifth, that's going to be 0. What's really important is that 2 is not a 0. That'd be 2 times negative 1 times negative 2 to the fifth. Not a 0. 0, it's not a 0. 2 times negative 3 times negative 4 to the fifth. Not a 0. Okay, so I just have two zeros here, 3 and 4. But if I look at this one, yes, you might see that negative 3 right away. You might see this positive 4 right away, just like this one. But here, when you plug in 0 for x, 2 times 0 is 0, 0 times anything 0. This is a situation where, yes, 0 is a 0. Like if you have x on the outside, 0 is a 0. When you don't, 0 isn't. You might list your x's like this, or you could just put them next to each other. Up to you. Now that we got that, all the other ones are going to be looking to factor as much as we can to solve. We might have to use a quadratic formula sometimes, but step one is always looking for a greatest common factor. All of these share an x to the fourth. Factoring is like dividing out. We practice this in unit 0. And all of these share a 6. So I'm going to divide out 6x to the fourth, leaving me with x squared. 6x to the fourth times negative x is negative 6x to the fifth. And then 6x to the fourth times negative 2 is negative 12x to the fourth. Think about dividing, undoing distribution. We did this in unit 0, and you guys did very well in unit 0. Quadratic, two numbers that multiply to get negative 2.
That is for you, for our students. That's a student that made her own company. And so,
What student?
it says on there.
I know her.
Yeah.
All right, I know the family. Cool.
So yeah, if
Thanks,
you want
man.
to order some, you can contact that number.
All right. Way to. I hope you're getting commissions for these, bud.
I don't know, maybe.
You should be getting paid. All right. I got a free cookie. I will eat that cookie too. The two numbers are negative 2 and positive 1. They multiply to get negative 2. They add to get negative 1. Yo, you got to make sure you remember distribution. Like x times x is x squared. X times 1 is 1x. Negative 2 times x is negative 2x. Negative 2 times 1 is negative 2. Make sure you know, like, the two numbers multiply to get this one, add to get this one. So once we get that, we are ready to find the zeros. Now here, since x is on the outside, like if you plug in 0, you get a 0. If you plug in 2, if you plug in negative 1. Okay, next one. They all share an x squared. I got x squared plus 3x plus 2. Two numbers that multiply to get 2 and add to get 3. Those numbers are 0, negative 1, and negative 2. These both share an x. This is great. Yo, probably best to start with this one on this side, and then we'll go to that one on that side. So let's factor out an x squared here, and let's remember. Difference of squares. The two numbers that add to get 0 x's, there are 0 x's in there, and multiply to get -5, or +5 and -5. This is what we call a difference of squares. X squared minus 25 is x plus 5x minus 5. So difference of squares, remember that. Now I get 0 because of the x squared. I get -5, I get +5. Cool. This is a difference of squares. Now the difference of squares is x squared minus 4 and x squared plus 4. Moving forward, we know when this could equal 0, there are imaginary numbers. We're going to pause on the imaginary numbers and come back to them on day 3. Instead, we are going to just talk about the zeros here, which is 0. And then if you want to take x squared minus 4 and set it equal to 0, you can either factor this, which is fine. You could factor this, or you could just add 4 square root and get plus or minus 2. Let's go ahead and factor. You cannot factor x squared plus 4. You could, or you don't have to factor x squared minus 4, so long as you get the 3, 0, 0, -2, +2. Cookie break. Oh, good. That's soft. X. Two numbers that add to get -6 and multiply to get 9. Got chocolate in my teeth. -3 and -3. That means 0 is a solution, and x equals 3 is a solution. It occurs twice. Now, we should actually be talking about their multiplicities this entire time. Maybe. X equals 4 occurs 5 times. Like 4 to the 5th means like x equals 4 has a multiplicity of 5. X equals 3 has a multiplicity of 1. This is important for understanding and analyzing your function. Both of these have a multiplicity of 1, and this has a multiplicity of 2. My bad for skipping this. 0 has a multiplicity of 4. Both of these have multiplicities of 1. This 0 has a multiplicity of 2. These two have multiplicities of 1. This guy's got a multiplicity of 1. All of them have multiplicities of 1. This guy has a multiplicity of 1. 2. These guys have multiplicities of 2. We analyze in class how multiplicities of 2, the signs don't change. You have a 0, but your sign doesn't change. We'll talk about how that kind of shows you that there's a bounce going on your graph if your signs don't change, but you hit a 0. Here, your signs won't change at 3 because it occurs twice. It's got a multiplicity of 2. Same thing here. It's going to be -5. Pause. Should factor. X plus something times x plus something gives me x squared plus numbers, x plus numbers. Two numbers add to get 10, multiply to get 25. X is 0 and x equals -5. This 0 has a multiplicity of 2. This -5 has a multiplicity of 2. It occurs twice. Now, we got to factor. When a is not 1, I'm just going to guess and check. I know it's got to be 2x times x. I know also 2 times negative 6 is negative 12. There's two numbers that multiply to get negative 12 and add to get negative 7. No, there's not. I think we made a mistake. If it was positive 12, I'd feel okay about this. Because it's not 6 and 2. It's not negative 4 and negative 3. Changing it. I don't want to do the quadratic formula right now. Okay. Yeah, 2x. 2x. It's got to be 6 and 1 or 3 and 2. And I get negative 7. I can get negative 4 with a negative 2. And I can get negative 3 with a negative 3. Negative 3x's, negative 4x's, negative 7x. If you want to do it your own special way with like grouping and Xboxing, great. I don't like it. 0. Add 3 divided by 2. We did this in unit 0, so I'm not going to go over it. 2. This is a multiplicity of 2. We are not going to change signs. This is a multiplicity of 1. I think that's what we were looking for. Negative 10. Okay, this one works out. We do want to factor this. Do you want me to do the box or the group? Sure. Two numbers that multiply to get negative 10 and add to get negative 3 or negative 5 and negative positive 2. Okay. I will have a box. This is just like grouping. 2x squared, negative 5x, positive 2x, negative 5. Yep. Factor out anything from anywhere as long as it makes sense. Like an x works from negative 2x squared to negative 5x. X times 2 is 2. X times 2x is 2x squared. 2x times 1. X times negative 5 is negative 5x. 1 times negative 5 is negative 5. So there you go. I just factored that. 3x times x plus 1 times 2x minus 5. X could equal 0, negative 1, and 5. Now, we started with that in class. Then we moved on to inequalities, okay? Because we find zeros. If we found all of the zeros, we know the signs have to be consistent between your zeros. If we find you got zeros at 0, 3, and negative 4, well, I'm going to throw down a number line with negative 4, 0, and 3. I know my signs are consistent. If the sign between 0 and 3 at one point is positive, all the points have to be positive. If not, there'd be another 0. So here's what we're going to do. For just these first two, we are going to just do some test points. And then we're going to notice something, and then we're going to use that from now on. Okay. All of these multiplicities are 1. Cool. This multiplicity is 2. This multiplicity is 1. All right. I'm going to use a test point like 5. I'm going to plug 5 into my original equation. I don't care about the values. I just care about the signs. Positive times a positive times a positive. 5 minus 3 is a positive. 5 plus 4 is a positive. That's a positive. Cool. All the signs have to be a positive. If they weren't, there'd be another 0. Going to plug in 2. Positive, negative, positive. Positive, negative, positive. Positive times a negative times a positive is going to be a negative. Cool. Negative 1. Negative. Negative. Positive. Also positive. -5. Negative, negative, negative. That's negative. Okay, cool. When are my values of my function less than or equal to 0? That means negative, like less than 0, negative, or equal to 0. I got from negative infinity until -4, but I'm including -4. I got from 0 to 3, and I'm including both of those values. That's when my values are negative. Cool. Now let's look over here. Again, just test points, and then we'll go on from there. -3, 2, make sure you put them in order. Looking at signs, using a test point. 3. 3 minus 2 squared, positive. 3 plus 3, positive. 0. 0 minus 2 is negative, but then squaring it makes it a positive. 0 plus 3 is positive. Okay, that's a positive. -5. -5 minus 2 squared is positive. -5 plus 3 is negative. So negative. These are zeros, so put down that we have a 0. When are we greater than 0? Well, we're greater than 0 from -3 to 2. We are not greater than 0 at 2. We are greater from 0 from 2 to infinity. Cool. Now, what do we notice? What we're going to use in the future. If your multiplicity is odd, like 1s, 3s, 5s, 7s, what you notice is that your signs will change because whatever your power is, your odd power, the signs will change or odd powers. Even powers, multiplicities that are even, no matter what you plug into this, the sign won't change, which is why what we'll find is that at even powers, even multiplicities, not at even numbers, it's just like an even multiplicity, a multiplicity of 2, we're not going to change signs. It is an easy way to fill out your sign chart by understanding multiplicities. And if you understand multiplicities and sign charts, you understand what graphs look like. Because what we're going to do later is be like, oh, this graph is going to be negative, then positive, then negative, then positive. Boom. That's what the graph looks like. This graph will be negative, then positive, and then 0, then positive. This graph looks like that. It's like a bounce. All right, so let's use that understanding now. X equals 0, x equals -2, x equals 4. X equals 4 as a multiplicity of 2. X equals -2, list them off in order, 0, 4. X equals 4 is the multiplicity of 2. All we need is one test point. I always like to go all the way to the right because I like positive numbers. They're easy to work with. -3 times 5 is a negative. This will be a positive. This will be a positive. Boom, big fat negative. When your multiplicity is 2, you don't change signs. You just hit the 0 and then you go back in the same direction. When your multiplicity is 1, your multiplicity is 1 here and your multiplicity is 1 here. When your multiplicity is odd, you do change signs. Boom. When are we less than 0? Here, here, and here. Negative infinity to -2, don't include it. 0 to 4, don't include it. 4 to infinity, don't include it. Got it? X equals -1. The multiplicity is 3. It's odd, which means if I plug it in and cube, the signs will change. X equals 3. The multiplicity is 4. This fourth power, when I plug in any value, subtract 3 to the fourth power, it will remain the same sign. It will always be positive. So what we see is we don't change signs at even multiplicities. -1. Whoops. You got 20 minutes. I think I can make it. 3. Test point. 5. These are zeros. It's important to write that down. 5. Positive, positive, positive. At 3, multiplicity is 4. Won't change signs. If you are not sure of this, use the test point. Okay, I can plug in 0. 0 plus 1 is positive, cubed stays positive. 0 minus 3 is negative, but to the fourth power is a positive. Okay, I just double checked. -1 multiplicity is 3, we will change signs. When are we greater than or equal to 0? Well, we're greater than or equal to 0 from -1 including -1 to infinity, because we're including 3. I don't have to like split this up. This is x is bigger than or equal to -1. Factor out an x. This will be x minus 4 times x minus 4. This will be x minus 4 squared. That means x equals 0 and x equals 4. X equals 4 has got a multiplicity of 2. X equals 0 has got a multiplicity of 1. I will change signs at 0. I won't change signs at 4. Use a test point like 5. I get positives. Don't change signs. Yes, change signs. When we greater than or equal to 0, same deal. Greater than or equal to 0 or from 0 to infinity. I got x squared. Okay. 0, 5, 1. Multiplicity of 2, multiplicity is 1. Multiplicities of 2, we don't change signs. If you're just like taking my word for it, that's fine, but like you should have done the investigation in class showing that multiplicities of 2 don't change signs. List them off in order. Zeros at 0, 1, and 5. We're talking about less than or equal to 0. If I plug in 6, positive, positive, positive. At 5, we will change signs. At 1, we will change signs. At 0, we will not change signs. Okay? When are we less than or equal to 0? Well, we are equal to 0 here, here, here. We are less than 0 there. So this is an interesting one. This is x equals 0 and from 1 to 5. Yeah, that's fine. A couple more, and then we'll get into the graphing. Factor out an x squared. That's a multiplicity of 2. The other multiplicities are odd. If you want to use test points, because that's the first thing you learned, fine. If you want to go and say, I'm not changing signs when my multiplicity is 2, great. Use a test point. Plugging in something like 5, positive, positive, positive. Change signs at 3. Don't change signs at 0. Change signs at -1. Cool. Use test points if you're not sure. Always good to check, like -0.5, positive, negative, negative. Wait, positive, negative, positive. If I plug in -0.5. All right. Less than or equal to 0. Equal to 0, less than 0. Equal to 0, less than 0. Equal to 0. I'm just going to say from -1 to 3. Yo, don't be scared. Get everything on one side. We like stuff greater than or equal to 0. That's where we can use the whole positive and negative deal. In nice order, that's x minus 5, x minus 1. Positive, negative, positive. Greater than 0. That's x is less than 1, and x is bigger than 5, we are not included. Okay, finish things off with graphs. We make a sign chart. Once we make a sign chart, we pretty much know what the graph looks like. Now we'll talk about why the ends have to start up here later. We got positives, negatives, bounce off, negatives, hit a zero, positive. That's what the graph looks like. Like, you want to see? That's not exactly like that, but like, boom, goes through, bounces off, goes through, bounces off, goes through. Maybe it ends up like lower than I expected, but at least I know the general shape of it. I know that we bounce off at zero. You see that bounce at zero. So cool. We don't really care how much it goes up or down, just like a general shape. All able to be found if you just understand the signs. Start by finding the zeros. I'm just going to go ahead straight to the sign chart. Understand their multiplicities. This is a multiplicity of 2. Get your signs. Plugging in 4, positive, positive, positive. Change signs. Don't change signs. Change signs. Positive values through 0. Negative values bounce off 0. Negative values go through 0. Positive values. That's where your graph looks like. X to the fourth, 4x to the fourth minus 36x squared. Yeah. Zoom out a little bit, maybe increase my Y's. Shrink my X's. There you go. Goes through -3, bounces off 0, goes through. Like, we nailed it. That's it. That's it. If you understand signs, you understand shape for the most part. 0, -2, 1. List them off in the right order. Sign checks. My mouse just went flying. If I plugged in 2, positive, positive, positive. Multiplicities all 1. Sign changes occur. What did my graph look like? Negatives to positives to negatives to positives. There's my cubic. Familiar to me. You can see it too. Okay, 4 more. I'm going to try to fly through these. Excuse me. Oh, that's my favorite. X squared plus 5x plus 6. X plus 3, x plus 2. 0, -3, -2. Maybe there's some more spacing so that you know, like, you're probably going down more because there's more space for it to occur. It's not like, it's not, it's not an exact science. So maybe we don't do that. Multiplicity of 0 is 2. If I plug the test point in like 3, positive, 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 don't change signs, change signs, change signs. So I'm looking at a positive through to a negative, through to a positive, bounce off, more positive. Okay, so let's see. Why is it not going back and forth? Big money, no ways, no ways. Stop! There you go. Goes through, bounces off. Beautiful. All right, plowing through. I said I was going to plow through, and then I just like paused and looked at my handiwork. Oh, this is our favorite. X plus 3, x plus 3. That means it's x plus 3 squared. That means x equals negative 3 has got a multiplicity of 2. My signs of my function, my polynomial, will not change. At negative 3. Negatives bounce off, negatives, positives. Oh, fun. Negative 3, 4, 5, 6. 7 is not that doesn't mean 7 is a 0 and 0 is not a 0. You don't see X. 5 is our multiplicity of 2. Positive. If I plugged in 7, all these are positive. Change signs. Don't change signs. Change signs. Change signs. Negatives. Probably going up a lot. Negatives, negatives, positives. I wish I could copy and paste this. I'm going to. I have the power. Copy. Paste. I go pretty far down. Did I screw up? You'd be bouncing off of 5. Oh, ha 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 ha. Yep. Other direction. Well, okay. Go up to the positive land for a while. Okay, cool. Come back down. We go through 4, bounce off 5, go through 6. We have a general idea of like the shape, even though like our y-axis is not included at all. We are not including our y-axis. Good. We can find a y-intercept. For all the other locations, like where do we go up to the top and bottom? We can't figure that out until we either have a calculator or have calculus at our disposal. Okay, -1, -2, -3, and 0. At least these will be spaced out nicely, so the graph will probably look a little nicer instead of going up so much. Multiplicities 2, multiplicities 2. The multiplicities are 1. If I plugged in 3, -2 times positive, 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 that means this is a big fat negative. We got zeros here, 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 here. Okay, hit of 0, don't change signs. Change signs. Don't change signs. Change signs. Negatives to zeros. Don't change signs. Negatives, don't change signs. Okay, let's see. All right. Can't really see what's going on, but we know that our bottoms are good. Let's shrink this back to. Oh, look at that. Goes up, bounces, goes down, bounces. Goes up, bounces, goes down, bounces. Isn't that cool? Like we kind of, we have a general idea of the shape just by understanding signs and multiplicities to make things easier. Hope we're understanding this. This is a fun little lesson. Not as conceptual, which we talked about in class. Very more algebraic in nature. Very less conceptually mind oriented, which is great. So I hope a lot of you are like, nice, we're back at it. Kind of similar to Unit 0, algebra and numbers. Okay? Messers out.